Ladies and gentlemen, we're almost finished our semester. We're going to try to keep new materials to an absolute minimum until then. And here we go. This is not even really a new one here. Acid-Catalyzed, that's a typo. Acid-Catalyzed hydration of an aldehyde is very similar to acid-catalyzed hydration of an alkene, which we learned in chapter 6. In fact, we'll do a version of this where we have it identical to the acid-catalyzed hydration of an alkene. And let's fix our typo here first. I got a little extracurricular R going on here. And what happens first is protonation of the pi bond, like in chapter 6. And then you want to generate a carbocation that's the most stable. Well, here's the pi. The acid here is per-iodic acid. It might not look like it, but that is HiO4. Per-iodic acid. There's a reason I chose that one. It's, oh yes. It doesn't like writing on that spot of the screen. It's torturing me. Here we go. Per-iodic acid. My favorite chemistry pun is per-iodic acid. I have this on the front cover of every exam because it has the same spelling as the other thing on the front cover of the exam, which is the, oh, there it is. The per-iodic table. Okay, I mispronounced that, didn't I? There we go. English, very funny language. Lots of words, same spelling, different meaning. And we've protonated that, and I want to point out that there's a very large portion of this molecule that doesn't change. Whenever that happens, we should feel free to circle it so we don't have to draw it again. And then we can say this becomes R attached to a carbon that has an O. And there's a reason I want to put the H right here and put the cation here. And the reason has nothing to do with hyperconjugation. None. Zero. There's something much more important than hyperconjugation, and it is the fact that these lone pairs, here's one of them, can resonate with the cation. If you put the hydrogen on the carbon, you wouldn't have this luxury. So now you've got your OH there. Don't need that lone pair. The OH part is done. You've got to get a hydroxyl on there, the same way we've been getting hydroxyls there all semester. It's from the water. Water will use its lone pair to make a bond to the carbon. R, O, H. And here we have something very similar to the final product. And it's at this time I realized that I didn't show the other product in the first step. And it was the conjugate base of per-iodic acid. Well, let's draw it a little better than that. Let's draw plus O3 I O negative on one of the O's. And that's the per-iodate ATE ion. And it neutralizes. And what you've generated is a product that's called a hydrate. Now, the hydrates, don't worry about naming them. You won't have to name them. and blank hydrate. And the blank has to do with what was it before it was a hydrate. And that answer is that it was an aldehyde. Aldehyde. So it's called an aldehyde hydrate when you're done. And that is the end of our hydration of aldehydes video. Real short one, finally. And we're gonna do periodic acid reacting with vicinal diols in our next video, because that's what periodic acid is well known for. See you then.